So let's see here. 2 times 0.5 times 3 times 7.86 plus 19 times 9.1. 196.48? Something squared? What? What? And then the last one was pentagon. Again, when you're dealing with pentagon, just like we did in our notes yesterday, all we have to do is draw our, well, we know it's twice the area of the base, perimeter of the base, how far apart they are. Our base is a pentagon, which is a 1/2 perimeter apothem. Yesterday in our notes, we did a pentagon. We found out that the outside angle by taking 360 divided by 5 got you 72, I believe. When you have 72 on the outside, that leaves you 108 on the inside, and we use half of that, which gives me the 54. Okay. Oh boy, this looks exactly like every other one of these problems, doesn't it? It's kind of nice that now that we've done this for a couple of weeks, you're just doing the same thing over and over again. So, tangent 54 is something over 1. Is our apothem divided by 1. What's anything divided by 1? Itself. So do I have to worry about that 1?
No.
Even if I multiply by 1, it doesn't matter. So really my apothem becomes the tangent of 54. $138. Okay. I start putting that together. You gotta go. 1/2 perimeter. 5 sides of 2 is 10. Apothem was 138, I believe. So there's that would be the area of my base. So I've already written that out, so I just start putting the rest of it together. Times 2, plus the perimeter of the base again, times how far apart they are. Because we know the perimeter is 10, you have 5 sides of 2, and the diagram tells you they're 3.5 apart, so it's just piecemealing together. Now, remember the base is always going to be which one has exactly 2 of the shapes. Okay. So in this case, like we talked about yesterday, the base doesn't necessarily have to be on the ground. It can be anywhere. Right? That was one of the reasons why I was showing you guys this program yesterday. That as the base is there, the base could be anywhere. It could be left and right. It could be up and down. It can rotate itself through it. It's always going to be, the base will always be the one that has 2 of exactly the same. Because remember, when we open this up, if we look at its net, when you deconstruct, if you will, when you deconstruct it, you're going to see that there's just 2 of these and a bunch of other stuff.
Oh, okay.
All right, so you're always trying to imagine what it looks like where there's just 2 of them, and that will always, always, always be your base.
Okay.
Okay? And remember, it doesn't have to be on the ground. All right? You don't have to say how low do you go. All right. Now,
You guys, I think the hardest thing about this really is identifying the bases. So if you just remember that the bases don't touch each other, right? They're parallel, and they're congruent shapes. They have to be identical shapes. Okay. My job is done.
I thought I was leaving too. I'm like, all right, sweet. We're like a team. I don't know. I just drink some more coffee.
No, you drink too much more. You chew.
No. Too much coffee makes me sleepy, believe it or not. You gotta get the right amount. That's not even close to the right amount. All right, so that's the first part of this first section. The second part of this, what we're gonna look at, are going to be cylinders. Now, cylinders, believe it or not, are actually even easier than prisms. Exactly. Do bases of cylinders ever change? No. The base of a cylinder never ever changes, okay? It'll never change. They're always going to be circles. What changes in the circles is just the size. That's it. So if you think about it, when you start talking about the surface area of a cylinder, when you talk about the surface area of a cylinder, you think you have your two circles, and then how far apart they are. It's the exact same formula. You're looking at twice the base plus the perimeter of the base and how far apart they are. But in a circle, or in a cylinder, what's the base always going to be? A circle. So do I bother writing it as twice the base? No, I'm going to write it as twice.
2 pi r.
Not 2 pi r, that's my circumference, but I'm going to write it as twice pi r squared. Because that's the area of the base. The circle, the cylinder always has a circle, so I'm going to write it as 2 pi r squared. Now, Whiskey, you were just saying 2 pi r. 2 pi r is your circumference, isn't it? Isn't circumference the perimeter of a circle? So instead of writing it as what we're going to do for cylinders, we're always going to use it in terms of their formulas because that never ever changes. Just dimensions change. Okay? So instead of saying perimeter, which we would have to add up and do all that, we know that every time the perimeter of a circle is found by 2 pi r. The h is really the only thing that stays the same, how far apart they are. So this is the formula that we will use for cylinders. And remember, if you really look at it, they're exactly the same formula. It's just that a cylinder, its base will always be a circle, whereas a prism, it could have been triangle, rectangle, a square, oh my, a pentagon, a hexagon, a nonagon, a dodecagon, a heptagon. It could be anything. 11gon, 37gon. Shut. All right. So the surface area of a 137 gon? Yeah, it is. Oh, yeah, you're right. Surface area cylinder will always be twice pi r squared plus 2 pi r times your height. Now remember, the way that we write, what's that? Surface area. Yes.
Like cylinder area, I was like, wait, what's that?
The surface area, our textbook uses SA for surface area, and they also talk about what's called lateral area, which is the area of the sides. You're never going to use the area of the sides because it's just
Well,
like,
if I said, what is the surface area of the sleeve on the little cup, it would be the lateral surface area.
but wouldn't that just be take the surface area of this and just back out the bases?
Yes, but I would have to know that. I could undo this and you could see that it's a rectangle then. Oh, sorry.
Do I have that on here?
Oh.
I don't think cylinders are in this.
No.
No, 'cause these are all, these are
Oh, it's all done.
lame. That's what I'm talking about, lame.
Oh, so today we're gonna be looking at the
What the
which
heck?
one do I
What is that?
triangle,
A-
something, something.
Some
made up shape.
Little chicken.
Wait, what is that? What is
That is, let me see, so you can read it better.
Hey,
That is a
Gyro
gyro elongated triangular
By
cup.
What does it look like together? Put it together.
Okay, give me that cup of coffee.
Wow.
That's a shape. It's like an eight-sided die.
It's not a shape.
Yeah.
Yeah, it is. It's a lot.
It looks like there's shapes.
There are, you guys, this is crazy. How about a parabi-augmented dodecahedron?
Like I need to know that.
By me.
It looks like a really messed up soccer ball.
If you look at it,
Oh, it looks like a soccer ball and a football together.
now look at what this is. This
Yeah.
is just this is a bunch of pentagons put together, but with one of the bases of the pentagon it's a pyramid on the edges. So it's a pentagon, a bunch of pentagons with pyramid edges.
Oh, so Jason's right. It's a soccer ball mixed with a
It's a
football.
Nerf football.
So that's what it would look like in origami. Let's see, what else is weird?
Do you like the last one?
Whoa, that's a
This one?
yeah.
This is a meta by diminished dodecahedron.
That looks like a soccer ball right there, but then it messed up.
That's
It's with a flat. It's a soccer ball with a flat.
It's messed up.
How easy would that be to kick though, because it would just be like nice
There's two flats.
and two flats.
Oh, that is weird.
It would be tough to have if you only have one
Oh,
spare.
wait, aren't they
Yeah.
different shapes? Oh, wait. Where's the flat?
Oh, it's.
Uh,
With the highest number.
What shape is that? How many sides is that quick?
uh, 8. That's a triangular. He can't pronounce.
Sounds like
He's sphenorotundra. Tundra. He sphenorotundra.
There's no R.
There's no
I
R.
feel like when you said reciting plant and animal names,
Tunda.
science class,
Yeah.
not math class.
All right. So there's that. Hey, look at this, Mr. Rouse. We got cool stuff. We have geodesic spheres and domes, and here's a 6-frequency icosahedral geodesic sphere.
It's a soccer
No, it's a disco ball.
Yeah.
Now, do any of you guys? All right, let me ask you this real quick. Any of you guys have epilepsy?
No.
Okay. Do any of you guys ever have a hamster?
Yeah.
Yeah.
Have any of you guys ever
Yes.
watched a hamster run in a wheel?
Yes.
Okay, so
Hampshire?
not
Hamster.
Whoa,
Let me get this thing to spin here real
That's
quick.
some good technology right there.
Doesn't want to spin.
It is spinning.
Probably like
It's not-
laggy. It would probably like lag too much.
No, it goes. All right.
We'll
So
have to do it together.
here's
Sideways instead of up and down.
now what I want you to vision real quick is what the hamster sees as it's running through it. Watch this thing rotate around as you're running through the object. The sides are going past you. That's the interior of this as it's rotating.
Just play it. 3 more seconds. You
Just
get
keep it
yourself
playing.
That's all fine and dandy, but can
So
you show me a
hard.
dodecahedron?
We just.
Pretty hypnotized.
You just looked at a dodecahedron?
We
Yeah,
have, we
we
have
go.
an every shape known to man except cylinders, so we're
Mr.
good.
Snyder.
Nice.
Would you like to see its net so you can make it out of origami?
Because you do that when you're not doing this, right? You're-
Because you have
I've got a
nothing.
lot of free time.
Yeah, you have so much free time, Mr. Rouse. It's unbelievable.
I've got a lot of free time.
This thing doesn't like to work on this one.
That's all cool. This is
So
awesome.
there's
No,
the origami.
It's
There's your origami.
That's sweet.
So I can print that for you. You can sit there and fold all day long if you like.
Put it on good cardstock.
Go back to the.
That would be a great birthday present for Miss Sabolsky. We should.
You're right, and I got to bring that down to her today 'cause it's her birthday.
Did you guys know that Miss Sabolsky's birthday is today?
Happy
They may
birthday.
have Miss Sabolsky as their counselor. Oh, you guys stop by and say happy birthday.
Happy birthday.
Have a great day, Mr. Murphy.
You too, buddy. Yes, sir.
Go back to that other shape and make it look like an origami thing.
Oh, the sphere.
Oh my god, it looks like a mosquito.
It looks like it would be like a hat.
Wait for it.
There's a bird.
Just see what we can make out of it. See what we can make
It's
out
like a
of it.
spider that has 2 main legs. It's a bird spider that died colliding.
It does kind of look like a spider.
That reminds me of my sister before she cut her hair. I didn't know Justice Glory called my sister cousin Ed at one point.
All right. Let's finish this real quick. I only really have one example of this for you guys because it is relatively straightforward. I'm going to give you. So we have, I think, 8 or 9 problems total for the weekend, and then we'll have a good 20 minutes to get it going.
So hopefully I can get it done in class? Yeah?
Mr. Murphy, how about
I
5?
mean, we could.
Yes.
How about 5 problems? That sounds a lot better.
Then he's gonna be like, well, we'll give you 12.
5 problems plus 2 extra.
Actually, I'm going to do 2. I'm going to do one like this, and I'm going to do one where we have to solve for
So
ourselves.
we have 2.
So we have a cylinder. I'm going to find the surface area of the cylinder by just basically writing down the formula.
We just add this on the last one.
That's what we're doing, yes, yeah. And I did all three of last night, so you shouldn't even have to worry about it. No.
I mean, it's easy to draw.
Like I said, I wouldn't worry about trying to draw them because
Just
they're
like right there.
yeah.
It's really easy.
I mean, in this case here, you know, it's a cylinder, so it's going to be 2 pi r squared plus 2 pi r h for the how far apart they are. What's your radius? 9. So to start putting it together, you have 9 squared pi plus 2 times 9. How far apart are they? 7 and a pi again. Now, in your calculators, you can type it exactly like that, parentheses and exponents and all that, and it will give you your answer in terms of pi. If you don't have that calculator, knowing that you're going to add something with pi and add something with pi, you can just put all the numbers together and put pi in it at the end. So I have 81 and 2 is 162 pi. 63 and 2 is 126 pi. Add those two together and we should get 288 pi squared feet. Yeah, I know what's up.
This one should have it.
Yeah.
So it's just G10.
All right. And then I have one example for you guys that we're going to work backwards for. What's up? Did you guys get it? Did you get it right? Typed in right?
No.
Jason, did you get typed in right?
Yeah. That's a circle.
We're going to go back to the rectangle here, the prism, and we're going to find a missing part. And like Mrs. Thrower was saying earlier, what's the oddball with the rectangle is that, excuse me, is that really any two of them can be a base. So a lot of times what you want to try and do is pick a part in the formula that'll be the easiest to solve for if you have a rectangle. In this case here, what do you think we should call the x? Should we use it as a base, a height, part of the perimeter, or just how far apart the two bases are?
Height.
Yeah, the overall height, like how far apart they are. I would do that for this one because then you can do everything else except for that. Here's what I mean. When we write out the formula for surface area of the pyramid, not pyramid, I'm sorry, prism, excuse me. Twice the area of the base, perimeter of the base, and how far apart they are. Well, big B is a rectangle, so it's a base in height. In this case, 5 by 7. All right with that? The perimeter of that is going to be 5 plus 7 plus 5 plus 7. Again, just using properties of rectangles, opposite sides are congruent, so you add all 4 sides up. Pretty quick. We get 24. Now, the only thing we don't know then is how far apart they are. Bless you. So, we know that this has to equal 142. So you have your algebra. 142 equals 2 5 by 7s plus perimeter times how far apart they are. And it turns itself into a very, very fast two-step equation. It turns into a very easy, very quick two-step equation. Okay. When you look at that, you get 2, 5, and 7 gives you 70. So we have 142 equals 70 plus 24x. Subtract the 70. Divide out, and you get a 3. Was it feet?
That's square feet, right?
Correct.
So we're just getting a linear measure.
I forgot the way. Look bad. 3 feet, because my labeling is awesome.
It's PX.
So just like every other formula or setup that we've done basically throughout the school year, we would always sit there and work through problems. We would always set up and work through the formulas. And at the very end, or along those lines, we'd wind up having to solve for a missing part. Hey, guess what? Nothing changes. Right? I need pictures. There's 9 of them. Very easy. If you want to leave one for one, that'd be great.
Okay, everyone has time, everyone needs to start working. If you need to work with your table partner, if you'd like to do that.
Say make. I give up. I don't want that. Nice guy. Sir? No, I did all of them. So there should, believe it or not, what I did here is I took an old worksheet and I just cut and pasted a lot of it together, and I kind of made it so that you'd have plenty of room to do it. All right. You're gonna notice that on real quick on number 6. On number 6, obviously again you have you have a pentagon again. Boy, it seems like we're stuck in a rut with pentagons. But notice what they give you. They give you a sides of 5 and a radius of 4. So you actually know 2 parts of the right triangle that's created inside that pentagon, which means exactly. You can use the Pythagorean theorem in this case. You don't necessarily have to jump and use any of the trig stuff. You can. You'll still get the exact same result within a couple of decimals here or there. But for the most part, you'll be just fine. Oakley dokley. Well, work. It's fun. Oh, I know. Time's always an issue with you guys. I get it. You know, next time I'll think to try to do that for you.